Hi, everybody. Again, my name is Andre DeVilliers with Ericsson. I work in Plano, Texas, as part of a network product organization that focuses on our transport portfolio. And by transport, I mean solutions like microwave radio, routers, as well as optical solutions. We're very excited to be working with Winncom. They are a new channel partner of ours. They are obviously, you guys all know who Winncom is. We're kind of new to working with Winncom and working with you guys, so we look forward to the opportunities that we can work together on. We are introducing our transport portfolio, particularly the microwave radios and the router portfolio, into the Winncom channel initially. And then over time, we're going to grow that with radio products and other products that kind of help you guys provide, a full round of solutions toward your customers. And we focus a lot on some of the big, tier one wireless operators, providing infrastructure for them, where we really would appreciate Winncom's help is other operators and others that can utilize and benefit our solution that we really don't have a direct sales force focused toward. So today's topic is 5G and CBRS Transport Networks. The agenda that we have in mind here today is to kind of talk a bit about what is 5G, and all the buzz around 5G and what does that for transport networks. We know a little bit about what 5G can provide in the radio network. I mean, for transport networks, how is transport changing based on the requirements of 5G and CBRS? We're going to look at some case studies where we study different customer types and what challenges those customers have, what solutions we've brought to bear in their networks, and what some of the results were and able to achieve with these solutions. Then we'll look at a number of those case studies, and then we'll look at some opportunities that you can focus on with your customers, and then kind of wrap it all up with standards on who to contact and how to start. I do want to mention before we get in that this is an interactive presentation, not so much on the Q&A. Initially, we're going to and take those at the end, but we are going to do a little bit of a poll, as you may have done on other webinars, but we're going to do this kind of outside. It's not necessarily integrated into this presentation, but we've kind of arranged for it on the side. So really, for you to participate and register your thoughts on the content, and it's kind of some of the the questions we might pose to you is go to menti.com, and then the code that you would when you go to menti.com, it'll just ask you for a code. You just enter this 6-digit code 79731. And then the questions, once we queue them, will pop up and you'll have an opportunity to answer them. It'll just give us an opportunity to understand how, what you're thinking and where we might kind of focus, our attention toward this community, both with opportunities and maybe, future. At any rate, look forward to hearing your thoughts. So what is 5G to us, to Ericsson? I hope that part of this presentation is because you recognize that Ericsson plays a major role in 5G networks across the globe. But there's a lot of buzz around 5G. A lot of people will use the buzzword basically to just convey that we can carry more capacity, or we want to do these cool things with wireless networks, and it's 5G. But really, 5G is a very specific set of standards and guidelines about what we're trying to accomplish. And there's certain use cases that we want to try to accomplish with 5G that we haven't necessarily been able to optimize for 4G and prior generations. So this is just some of the things that 5G enables, and some of the guiding posts that all work in 5G tries to ensure that we're going to be able to meet, both from a technological standpoint as well as regulatory, software development, things like that are all going to be working toward these aspirations. So 5G. What are some of the performance boosts that we would expect in 5G as prior to opposed to prior generations is obviously in capacity, downstream up to 20 gigabits per second to a user. That's incredible. That's not even heard of right now. Right now we're lucky if we get one gigabit per second to a user, which is great. So just think of the the rich content that can be made available with that sort of capacity. And then 10 gigabits upstream obviously makes that content and those sort of user experiences much more dynamic and interactive. Latency is a big component of 5G. 1 millisecond latency is kind of what's being worked toward, and that will enable things like critical infrastructure to be monitored and to have interactions with that on a very dynamic basis, or very low latency basis, so that you can do things like gaming and augmented reality and some of the things that are going to require super low latency. Positioning accuracy to 3 feet and mobility to 320 miles an hour enables some obviously highly mobile applications. I think our idea behind 320 miles an hour is to be able to offer service on high-speed rail. 5 nines or 99.999% availability in networks is something that those of you who've designed microwave links is familiar with. I mean, 5 nines of availability is about 5 minutes of outage per year. But when you take that to an end-to-end basis across your entire wireless network, now you're talking a whole new level of reliability. And those sort of things are needed for applications such as remote medicine, perhaps. There's a lot of remote control of devices and sensors, and maybe even surgery or something like that would absolutely require high availability. But we're also talking about sensors and Internet of Things and devices that can be very simple, that don't require a lot of bandwidth, but they're very numerous, and they need to have battery life that lasts years and years. So things like 2.5 million devices per square mile, or a 10-year battery life, are speaking toward the massive IoT sort of environments. So here, we sort of capture what the major use cases are in 5G. So we all know mobile broadband, what's on the bottom left. We all know that 5G is going to enable higher and higher capacities and provide us richer and richer content. So there's always going to be an enhancement to that, because that drives a lot of a lot of our economy, really. But speaking toward the other requirements that I mentioned, massive IoT to enable to put 5G in sensors and enable industrial networks to make decisions and act on state in its environment that without human intervention, that is like we have use cases like a wired vineyard, for instance, where sensors that monitor the amount of water levels in the soil for this patch of a vineyard can interact with all the other sensors and the vineyard operations overall to know basically when to water, or whatever else you can do to kind of enhance the environment for those grapes. critical IoT like remote surgeries and utility operations and things where low latency and high reliability are needed for kind of mission critical operations. That's another major use case. And then finally, we'll also talk about fixed wireless access. So now that we have a wireless infrastructure that provides capacities that outperform in many cases the wired infrastructure that you can get to a particular location, now we've enabled a situation where a wireless operator or a wired operator who wants to improve service to a particular location can offer a wireless service and serve those that have either been unserved or underserved. So fixed wireless access is a kind of a major use case for 5G. So one of the things that Ericsson does as being kind of instrumental in the wireless industry is we issue something we call the Ericsson Mobility Report, which is a yearly look. Every fall, we look at the state of the wireless industry, and we make predictions about, capacity growth or applications that are going to be important to, to the future. So I encourage you to look this up. It's a public report. You can find it on our website. It always kind of pushes the state of the art in terms of what we can be thinking about. But if you go back and look at past mobility reports and look at where we are now, you'd be surprised how many things actually come to fruition. But it's always a good source for kind of understanding where the industry is going. And one of the things that the Ericsson Mobility Report just last published here in November predicted is, now that we have started to build out 5G networks, and with the capacity that 5G networks can provide, we can expect that traffic is going to be, steered toward those 5G assets as soon as they kind of come online. You have your legacy networks, 2G, 3G, 4G, providing a nice base of coverage and some capacity, but up to 50% of the capacity that networks are going to provide in 2025 will be on 5G networks. So, that's a, kind of a large, that's an important, statement that, now we need to prepare our networks for 5G. Video, well, of course, video really has driven to this point the uptake in capacity over time, and it will continue to do so. And it's not just because teenagers and young adults like to watch videos everywhere they go, but it's because content, apps and content providers are providing richer and richer experiences with video, either part of a social media feed or part of virtual reality is maybe part of particular apps experience. So those things will, those types of content will continue to improve and obviously consume more and more video, and which will we'll obviously see that continue to be a big factor as we go. And so 5G is not just a buzzword, it's a whole ecosystem. It's a lot of different aspects of the industry working together to make this happen. We have the standards, the 5G standards that are in place to kind of provide the guideposts toward building these things, but you have regulatory activity where different bands of spectrum are now being made available, and specifically in mid bands and in high bands being made available for 5G coverage. We have some carriers who are going to implement 5G in low bands. So there's a lot of creativity out there in terms of how these are going to be utilized. Radio functionality, obviously there's state of the art in radio when it comes to higher and higher modulations and beamforming and MIMO and various standards of CPRI, which we'll get into. that's another line of activity that's aligning for 5G. Coordination. So really smart software is allowing you to optimize the spectrum assets that you have and how they're being used, whether it's something like dynamic spectrum sharing, which allows you to run both LTE and 5G in the same spectrum and allocate it dynamically. That is something that our software enables. Aggregating across carriers, across radios bands, and coordinating amongst radios that are in the area. All of these things, these coordination services are, part of the 5G standard and part of the 5G experience. And then, of course, last but not least, certainly are the devices that are, that everybody are attached to, and that, are the end recipients of all of this technology. So before we jump into what it means for transport, it would be, I want to kind of pause and make sure that I mention CBRS. And CBRS isn't necessarily 5G, but it can be used for 5G in the future. It is important because it is also creating a buying cycle, just like 5G is, because CBRS, if you're not familiar with it, is 3.5 gigahertz of spectrum, 3.5 gigahertz band, 150 megahertz of spectrum. But it's being licensed in a very interesting way, in a dynamic way that accounts for the incumbents that are using that spectrum. It accounts for those that have acquired licenses for portions of that spectrum, but there's a portion of the spectrum, the GAA, General Authorized Access portion of the spectrum, that is, can operate with no license, and therefore it can be shared on a somewhat dynamic basis. So this enables those entities that do not have spectrum or don't have a lot of spectrum to add spectrum or get any spectrum at all and start offering wireless services. So this has been big for wireline operators, for instance, that need that last mile solution for a fixed wireless offering. This has been big for WISPs, for instance, that are used to using wireless unlicensed, particularly spectrum, and adding a licensed component to its spectrum arsenal, if you will. And it gives them, maybe a more reliable solution for that fixed wireless, asset. So the other phenomena, I guess, happening now is that there is governmental activity around providing funding for unserved and underserved areas through the Connect America Fund and the CAF and CAF2 kind of funding cycles. And there are operators that are gaining, federal funds that allow them to, build out in areas. So all of this is creating buying cycles for wireless or entities that want to become wireless operators that will have impacts on their networks and the preparedness of their networks to carry all this traffic. So that's where the transport network kind of comes in. So is your network prepared for the evolution to 5G and CBRS FWA, for instance? So where we're going is we're going to a state where if you want to have superior RAN performance, it absolutely is a de facto state that you have a superior transport network. So I mean, that's the quote at the bottom is from our CTO a while ago, but it we're very radio centric. So for our CTO, who's very much a radio person, to come out and say the only way for us to be successful in radio access performance is to make sure that we have superior transport networks as well, that's a big statement. So what this slide is kind of showing is that in your baseline LTE networks over on the left, we have capacity requirements in the 100 megabit range. We have interfaces that are on the gigabit Ethernet range, and we have sync solutions that really only require frequency sync, GPS, for instance. And we have backhaul technology that's divided somewhat between microwave and fiber, and it is a kind of a distributed RAN where the the radio basebands and cell sites and radio assets, radio heads are, all located on cell sites, remote from other parts of the network. This has been kind of the de facto architecture and state of things, throughout all of the Gs, if you will. But now as we move toward trying to provide gigabit service, even starting with LTE evolution, when we're trying to provide gigabit service to devices, now we're doing some smarter things with spectrum. So we want to share spectrum, but we can, if we have an operator that has low band spectrum, say 700 megahertz, and mid-band spectrum, say 1.8 gigahertz, and they have spectrum assets there. If you want to provide higher bandwidths to those devices, then what you can do is pull those assets together through carrier aggregation. So LTE evolution allows for carrier aggregation across these bands. Well, that drives transport requirements even more. So now we're talking about some sub-gigabit service, but in a lot of cases, higher capacity requirements beyond a gigabit, which requires 10 gig interfaces. But at least it's a mix between gig interfaces and 10 gig interfaces, and in your transport network. And then there's a growing need for time and phase sync as well. And then you start to see the introduction of CBRS, which is the protocol that is more or less proprietary between radio providers, between their radio heads and the basebands. And so CBRS is very bandwidth intensive, and that has created its set of transport challenges as well. It has very low latency requirements in order to deliver the things that it needs to deliver. But then as we go, and kind of where we are now, as we go into the growth of 5G on mid-band and even high band, so the next two columns, you see more and more of, you're going to be aggregating capacity across, more and more spectrum assets. So now that's going to drive capacity certainly toward the 10 gig range, potentially even multiple 10 gig or even 25 gig range on some sites. And that's, and then of course, you have a growing need and almost a requirement now for time and phase sync. So technologies like PTP and the ability to distribute to PTP become incumbent on your transport network. And then, we still have microwave and fiber, but we have growing need for more and more CBRS. And then specifically, how do we manage that beast that is CBRS and put it in formats that can be carried over a reasonable transport architecture? So we've got eCBRS, which is basically CBRS encapsulated into Ethernet frames. We're not going to focus too much on that in this particular webinar. It may be a good function or a good topic for a future webinar, but just suffice it to say that each one of these kind of innovations in the radio network creates architectures like you see below. You've got something called DRAN, distributed RAN, CRAN, centralized RAN, ERAN, elastic RAN, and VRAN, virtual RAN. All of these architectures are kind of created by these innovations, and they all have their own capacity and latency requirements that drive unique solutions in transport. So another way to look at it is here on this slide. Basically on the top, you have these features that 5G radio is taking advantage of and providing. So more spectrum, more bands, coordination, disaggregation, all of these things are driving the requirements here on the bottom for capacity, number of sites that you can manage, ultra low latency, synchronization, automation, network slicing, which is basically kind of taking a chunk of the end-to-end view of a network so that, and those assets can be shared for a particular customer across the network end-to-end. And so enabling that has its own set of requirements and issues. This particular slide here shows kind of the result of some work that I believe our microwave R&D people did a couple of years ago. And it was a projection toward where backhaul capacity was going from the time of the study in 2018 to almost now, but maybe in the year or two here, 2022, and then ultimately toward 2025, when we expect half of that traffic to be delivered on 5G. So you can see that the types of sites on the left are categorized into
Hey, Andre, we lost your audio. Can you hear me?
5% of the sites are, carry 80% of the traffic. Just Elaine, can you give me a quick check on my audio?
Yeah, you know what? It's good now. Something happened there for a minute, but you're
I
good.
got a phone call in the middle of that, and sorry, and I
Okay.
didn't get the feedback in my ear, so I didn't know if I was still connected. But
Yeah,
glad
it's
here I
good
am.
now.
Okay, so urban sites, suburban sites, which are, about 15% of the sites, 15% of the traffic, and rural sites, less than 5% of the traffic, but they're 80% of the sites. So you can kind of see how capacity is projected to grow across all of these sites. And kind of the moral of the story is that even though we're talking about 20 gig, per second capacities at some of the sites, we have to have specialized solutions for that. We still have a vast majority of the sites that are going to be capable of being served by sub 5 gig, probably in a lot of cases sub 1 gig backhaul capacities, and therefore, you should feel good about the ability of technologies like microwave radio to be able to serve that. We do have solutions that allow you to aggregate channels across microwave links, and we'll talk a little bit about that here as we go. But that's one of the kind of the morals of the story. But I thought that was a good one to share. So as we go into 5G deployments, we're going to see more and more trends as it relates to 5G transport. I'm not going to cover this in a lot of detail, but it's more or less like this. We're going to see more and more microwave because 5G, and especially with millimeter wave, means it's going to be more sites that are going to be required to be built in order to provide the coverage needed to kind of say you're fully covered by 5G. But the coverage area for millimeter wave in particular is much smaller than it is on low bands, obviously. So there's a need to have more and more sites, and those more and more sites need to be smaller and smaller, and probably in areas that are either not served by fiber or maybe hard to serve by fiber or much fiber. So that's going to create opportunities for microwave, and particularly small form microwave. Similarly, there's going to be more and more front haul as we build, especially in dense urban areas, as we build centralized RAN networks where we, for various reasons, for radio optimization, we want to pool our basebands together. So that creates these CRAN hubs. But all of those CPRI links that permeate from a CRAN hub, need to be fiber fed in most cases. We'll go through an example where that maybe isn't the case, but and then so there's a lot of innovations on front haul. So there'll be more and more front haul and innovation specifically in the area of eCPRI, and how can we kind of encapsulate CPRI in Ethernet frames so it can be more optimally transported. The third trend is going to be around enabling some end-to-end capabilities like mobile edge computing, automation, and network slicing. It's really not the topic of this particular webinar, but we can certainly provide information on that perhaps in a future one. But suffice it to say that there are end-to-end capabilities that will also have impacts on transport networks. So like mobile edge computing, for instance, is a lot about where do you put the compute resources in a network? Do you put them close to the devices? Do you centralize them? And being able to make that decision based on the type of workload it is the optimal way to do things, and that's going to have impacts on what your transport network's going to look like. And then finally, I kind of already hinted at it, small cell and small form factor innovations. So not only do we have radio devices that are optimized for being delivered on a pole, but we also have front haul and backhaul solutions that can complement that. So it's important that we, like I said, when we have more and more sites that have maybe sort of different availabilities for backhaul and front haul, then we have to be innovative there. So kind of when we see 5G, kind of on the horizon and really kind of coming now, we see all of these requirements on capacity and latency and security and features like network slicing. And you see, kind of as I said before, when you're talking about end-to-end performance, it becomes less a function of how smart and how cool your radios are, and more. I'm not saying they're not important. Obviously they are, but transport becomes a more and more of a component in how well this whole ecosystem works together. So, as we'll talk about through the use cases, you're going to see solutions that are state-of-the-art microwave, as well as well, we won't talk about front haul today in too much detail, but we have integrated compact front haul that is optimized to different kind of installation scenarios. And then we have access routers ensuring high performance radio. This slide here in particular shows kind of the one profile view of the Ericsson Transport portfolio. We have our front haul family on the left side, which is, like I said, a mix of both indoor and outdoor solutions for carrying CBRS, both active managed sort of solutions as well as passive unmanaged solutions, and they can be installed in a variety of places. You'll see pole mounted solutions. You'll see solutions that like the ones on the bottom right in the second row, up in here that are made for like being installed in handholds underneath the pole. Then we have in the middle area, we have our Minilink portfolio, which Minilink as a brand name has been around since the 1980s. We've deployed something like well over 4 million radios, well over 4 million of these and the predecessor radios in wireless networks globally since that time. The first million took a while because networks weren't that big, but as networks got denser and denser, the second, third, and fourth million radios came on very quickly. So we're well past 4 million radios at this point. And so we'll talk some about those. And then over on the right, we have our router portfolio that's kind of optimized for our radio networks. It does a lot of things that make our radio better. And then finally, we have some partner products that we won't focus too much on today, but they somewhat complement our our router solution. So where we have kind of focused our router 6000 is really on the access network side of things. Our partners kind of focus on the core routing and edge routing, security, and then some long haul optical needs that kind of provide us an end-to-end portfolio when it comes to transport networks. Okay, and then finally, before we take the poll question, I just want to mention that 5G is here, and we have 32 live networks worldwide that Ericsson is involved in. So this is carrying traffic now. We have 91 commercial agreements for 5G networks. And in those networks, 60% of those networks are using Ericsson Transport. So the products I mentioned before, the 6000 Minilink series, as well as the router 6000 are part of the. So I think it really kind of shows that customers are kind of putting faith in the fact that radio is complemented by good transport solutions. Okay, so before we jump into a number of use cases, we're going to take a pause here to ask a poll question. So just to remind, kind of remind you of the what we're doing here, go to menti.com and plug in this code here, 797319. And the first question is going to be, can you list 2 backhaul challenges that your customers are facing today? Okay, so I'll give you a moment to do that. And we'll start up here in a minute. Again, think about your customers. Doesn't have to be a wireless customer. Doesn't have to be, really anything we've talked about so far. But your customers, what are some of the transport challenges that they're facing as they look to evolve their networks? Okay. Well, I hope you've had an opportunity to do that. I'm going to move forward in the presentation so we can stay on schedule. So let's look at some case studies. We have a number of case studies that we're going to talk about right here. So, for instance, here's the first one where we have a customer who, as I mentioned before, we have CAF funding. This customer won some CAF money to build out a number of sites in the Midwestern US. They have elected to use Ericsson LTE for their access solution, and they're going to implement a fixed wireless access network with that. They, to date, have been using a mix of different vendor products and really needed to kind of consolidate to kind of mature their operations. So we, on the transport side of things, we complemented the solution with 2 solutions in particular, with a next generation cell site router, called the Router 6471, which was going to prepare them for the future, number one, by providing those 10 gig interfaces that they needed, and aggregating the backhaul capacity from each of the radio basebands. Our radio solutions have a number of requirements, and a particular site may require 1 baseband, may require 2 or 3 basebands, potentially even more, depending on how complex the site is. So it's important for you to have an aggregation point. Similarly, if each of those basebands needs synchronization, it's much cleaner to allow the router to distribute sync back to the basebands rather than deriving sync from separate GPS or separate feeds from the same GPS antenna. It's actually much less expensive if you let the router do it than if you have separate feeds for each of the basebands. The Router 6000 in particular has been designed to provide deep buffering of TCP traffic because we know from years of building wireless networks that TCP traffic is created or subject to a lot of retransmissions, and if we don't buffer that in wireless operations, then it's going to be a much less pleasing experience for the end user. And then, of course, it's important to mention that the operational aspects of the router, such as being part of the same building practice, such that air flows in the same way, power is handled in the same way, managed by the same operation system, are all kind of part of that. So, that allows basically everything that goes inside of a radio site enclosure to work and feel and look the same way. And so that's an important part of the solution. To complement that from a backhaul standpoint is a multiband microwave solution. So we're not talking about, just in this case, 23 gigahertz, which is a licensed band. We're not talking about just purely licensed band. We're talking about license in combination with E-band. So for short hops, which this customer had between its fixed wireless access points and its kind of core network, then it needed these short hops. So with the multiband solution, you can essentially aggregate the capacity that both the 80 gigahertz link and the 23 gigahertz link are providing. And in our case, we do it at layer 1, which is 100% efficient. So in this case, you have E-band providing 2 gigabits per second and 23 gig providing 500 meg per second. So that aggregate capacity actually comes out as 2.5 gigabits per second per site. The E-band is actually expandable to 10 gig if your link budget, allows it. So what this allows is you to stretch E-band in a way that can deliver greater capacities over a longer range, but then you still have a lower band that provides that availability that you need to keep the link alive. And we use some smarts with basically policy-based forwarding in the Ethernet portion of our radios, such that we can assign the important committed information rate traffic to the lower band, the higher availability band, and then the peak traffic on the higher band, which is going to, by physical law, going to have lower availability. And then you can kind of see the footprint of that site is really not much more than what you would have with a single radio and antenna. But this is a dual band antenna that serves both bands. And we have solutions that allow you to have up to 2 traditional band and 2 E-band radios all combined over one dual band antenna that could deliver, in theory, up to like 22 gigabits per second. This particular solution would deliver up to 10.5 gigabits per second. For this customer, they wanted to engineer it to 2.5 gig. So that's how we're supporting them with CBRS. Next use case would be for campus network. So this isn't necessarily a wireless operation, but we're using wireless to extend a fiber footprint. So something we call fiber extension. We have a large national communications provider, in this case, the enterprise operations, where they are looking at providing connectivity to all the buildings in the campus, whether it's college campus or multi-dwelling unit or something like that, where they could only get fiber connectivity at 1 or 2 buildings in the site. And rather than dig up the campus to string fiber together amongst all the buildings, we just use these simple wireless solutions, either E-band, Mini-Link 6352, or V-band, 60 gigahertz unlicensed product, 6351. We use those on rooftops and connect them from rooftop to rooftop. And then from a networking standpoint, we can make this a little more resilient so that we have some backup and protection just from a topology standpoint, and ultimately deliver that capacity to each and every building, and then use inside wiring techniques to distribute it within the building. But this kind of gives that particular customer some some ability to provide service to this campus quicker, and of course derive revenue from providing that service a lot quicker. Similarly, we have tier 1 operator will often need to support events such as sporting events or festivals, or things that basically bring a high density of people to one location that for 99% of the time otherwise doesn't really need that level of capacity in the system. So what they do is they bring these temporary sites, a cell on wheels, a cow. They bring them to these venues. They deploy the cow in a place that makes sense from a coverage standpoint and capacity standpoint, but it may not make the most sense from a backhaul standpoint. In other words, they may not have fiber there. So another way to deliver backhaul to such a temporary site, of course, is through a microwave link. In this case, it would be through an E-band microwave link that can deliver. In this case, this customer delivered 1 gig and 5 gig capacities to several different events using our E-band product. And these sites ended up carrying terabytes of data over the course of the event. And we have a nice quote from the customer about how easy this radio is to set up, so thought we'd include that here. A very similar use case is around front haul. So we have tier 1 operators that when they build their networks, they typically a radio site is going to propagate in 3 different sectors in 360 degrees around the site. so each one at 120 degrees. But for instance, you may have a site where one of those 120 degree sectors is blocked by a mountain or a building, or if you were to deploy a site in a traditional way, you would basically be wasting that asset to put the sector there to shoot the side of a mountain. Well, why not try to capture the customers on the other side of the mountain or the other side of the obstruction by extending that sector to that location? Well, to do that, you would need to extend the CPRI link, and to do that with the latency required by CPRI in a wireless capacity, you can utilize the 6392, which is basically the same E-band radio. We've just taken the Ethernet framer out and inserted a CPRI framer. So CPRI, is very bandwidth intensive. Can depending on the variant of CPRI, can require up to 10 gigabits on up. In this particular case, the customer was using it for CPRI 3 at 2.5 gig and CPRI 7 at 10 gig. So it gave them a very nice solution for for getting the most out of their radio assets. We probably need to move a little quicker here, but we have two use cases that I'll talk about very quickly. One for a utilities operator, and one for a communications operator in the Gulf of Mexico. Both cases are not, they're both private networks, and in both cases, the customer had its own spectrum and used our LTE radios in order to build out that spectrum and provide kind of private networks for its customer, basically for the utility or for the oil and gas company. But we also did the microwave network backhaul, the microwave backhaul for these networks as well. And so it really allowed for, in the case of the utility operator, it allowed for them to modernize their network. As you may know, some of you probably have utility customers as customers. It takes a long time for them to upgrade, and there's still a lot of old technology that's out there. This gave this particular utility a nice upgrade path and really modernized their network. In the case of the specialized network for the oil and gas companies, it allowed not only for these oil rigs in the Gulf to communicate with each other, but they were also able to use excess capacity in the network and offer it up to cruise ships as they were passing by. So the cruise ships had some continuity of coverage as they went by. So a nice customer quote here as well. And then obviously in the Gulf, you have a lot of over water communications that require some intense microwave designing that our radios were stepped up to the challenge for. So next poll question, guys. So based on what we've talked about for 5G transport requirements, and then in these case studies, are there two opportunities that you can think of where you might be able to apply such solutions for your customers? So again, go to menti.com. You should already have the code 797319, and then if you can brainstorm about a couple of opportunities where the solutions you've heard today could be applied in your customers, then that will give us a nice little database of information that we can better position our products for you guys. I'll give you just a minute. Okay, we're going to leave that open, and hopefully you can, continue to, to write your answers there as we finish up the presentation. Okay, so now kind of turning it toward this audience and toward you, toward your customers, where are some immediate opportunities where you can, potentially approach your customers and have them upgrade their transport networks to enable them for either 5G or CBRS fixed wireless or whatever their network upgrade path is. So if you look first at on the microwave side, there's a number of areas where you can kind of focus. Certainly in urban areas, especially in those new sites where fiber is not available or fiber is expensive to deliver, we want to look for opportunities where we can put our small form factor E-band and V-band products to use. So gigabit capacity on up, short distance, that's perfect for kind of the dense urban areas. And then similarly in suburban areas, you may already have existing sites in place, but those existing sites need to grow in capacity as service starts to become upgraded out there. So we want to provide a capacity growth path for those customers. So we can utilize wider channels and higher modulations. We're just releasing a radio, actually, I think here this quarter, that's capable of 8K QAM modulation, and then ultimately to 16K QAM modulation. So that provides, percentage more capacity in the same channel bandwidth. And of course, there's ways to combine carriers into, use multiple channels to combine those carriers into higher and higher capacities. And then you can combine that not just in the same band, but with E-band or, other bands. So, we encourage you to approach us with those opportunities. Can we combine 18 gig and E-band, for instance, with a single dual pole, dual band antenna? Yes, we can. We can provide some pretty compelling solutions there. The third opportunity is around fixed wireless access, as we talked about in the first use case. Can we use either E-band or license band or a combination to provide the fiber complement for the backhaul and fixed wireless. And then for the rural applications, kind of 4 and 5 together, we certainly need to increase capacity, but just to provide coverage and maybe even a backup solution to these areas that are more remote and more costly to get to for maintenance. We can look at providing our licensed microwave there, or even our long haul microwave solution, which we talk a lot about today. But those have been utilized in very remote areas where they even have to be solar powered, for instance. So those are some things we can help with. On the router side, similarly, there's many opportunities that you can look for just today. So I think the most immediate one is are the routers that your customers using, are they prepared for 10 gig? Not just 10 gig on the network side, but 10 gig toward the radio basebands. Excuse me. That's going to become more and more important the more that we add, mid-band and millimeter wave. Outdoor access. Again, having a variety of building practices so that you can install routers in outdoor environments as well as indoor environments. Those are things we can help with. We do have an all outdoor router that provides 10 gig access. And then as we go up in the network, again, centralized RAN hubs really enable things like elastic RAN, which we won't really cover a lot here, but the role of a very low latency layer 2 switch, not just the router, but the switch, is instrumental in CRAN. And there we have a kind of the perfect solution for that. And then as we go up or higher in the network, we have the backhaul aggregation, which tends to need to happen at the 10 gig, maybe even 25 or 100 gig level. And then of course maintain that low latency and highly dense form factor. So I think these are some things that you can start to approach your customers with today. So I'm hoping that your next question is, well, how do we get started? How do I kind of access these solutions that Winncom and Ericsson are making available? So first, for sure, we should mention that you have a sales team at Winncom. You can contact either directly through the rep that or here at the sales@winncom.com email address, or you can submit a request form that you'll see on the site. So Ericsson has a microsite that's part of the Winncom site. You'll see this form there. You'll also see some additional information. We've got obviously information about the products that are there, the things you can order there, but also we've put a number of white paper links as well here. Things like, what is a cell site router, and why does it change with 5G? What about synchronization? What's so important about synchronization for 5G? So a lot of these topics are talked about in some detail on these white papers, including the I was talking about the Ericsson Mobility Report prior. We also have the Ericsson Microwave Outlook, which is kind of the microwave complement to that, where we're looking into the future of microwave. So with that, I will leave you with one last poll question. I hope that today's content has taught you a little something, and maybe got you interested in working with us through our Winncom partners. But in the future, we're certainly open to presenting more topics. And if you have 2 topics that you would like maybe to request, then go ahead and put them on the Menti form now. I think while we're doing that, and I hope you guys have some great ideas, we certainly have a lot of expertise in Ericsson that we can bring to bear for future presentations. But I think this might be a good time to open it up to questions and answers.